This time we are going to solve the circuit using the Thevenin's theorem. So the very first thing which I'm supposed to do, I'm supposed to simply find the VTH, Thevenin's voltage. Okay, in order to do so, I'm supposed to open the load, my resistor RL. I have to open it. So my circuit right now is going to look like this. I have voltage source, and I'm going to have resistor R1, and I will have resistor R2, and I have resistor R3 and resistor R4. Okay, and as I said, we have to take out the resistor RL, and we're supposed to find the voltage between these 2 points. I can call these 2 points point A and point B, for example. So voltage VAB is going to be equal to my Thevenin's voltage VTH. Okay, so now please keep in mind that this is open circuit. Okay, this branch is nothing else, just the open circuit. So please keep in mind that open circuit in the electrical circuit is recognized like a very large resistance. Okay, so, and also keep in mind that the highest voltage is going to always concentrate across the highest resistance. So if this is the highest resistance between these 2 points, because air has very large resistance, so the voltage which will occur across resistor R2 will also appear between these 2 points. So if I'm going to find the voltage across this resistor, the same voltage I'm going to have between these 2 points. So I'm going to write that my VTH, let me write this down over here, VTH is equal voltage across resistor R2 in this case. And I'm going to use voltage division law in order to find VR2 or VTH in this case. So this is nothing else as voltage source times R2 over the sum of these 3 resistors, R1 plus R2 plus R3. Okay, don't forget that you're supposed to write always formula first. So VTH is equal voltage source 20 volts, open parenthesis, and I have R2 which is equal to 2 kilohms over R1 plus R2 is 3 kilohms plus R3 is equal 4.5 kilohms. I have 4.5 kilohms, and this is equal. I'm going to use the calculator to find this voltage. So I have 20 times 2 exponent 3 divided by 4.5 exponent 3. This is equal 8.88 volts. So I have 8.88 volts. So this is my Thevenin's voltage. In order to find the Thevenin's impedance or resistance in this case, I'm supposed to short my voltage source. Okay, this is my voltage source. So in order to do so, I'm going to redraw this circuit again. But this time I'm going to short my voltage source. So my voltage source is shorted, and I have R1, and I have my R2, and I have R3, and I have R4. Okay, next, in order to find the Thevenin's resistance, we're supposed to find the total resistance of this circuit by calculating the resistance from the points A, B. Okay, if you are going to find the total resistance from this side, this is going to be equal to the Thevenin's resistance. So first, please realize that resistor R1 and resistor R3, they are in series. Okay, so I'm going to find the total resistance of these two resistors first. So I'm going to write R1, 3. Okay, so R1 plus R3 is equal, R1 is 1 kilo ohm, R3 is equal 1.5 kilo ohm. So let me write this down. So I have 1 kilo ohm plus 1.5 kilo ohms is equal 2.5 kilo ohms. Please notice that the branch with resistors R1 and R3 is in parallel with resistor R2. That's why I'm going to redraw the circuit again. So let me just draw the R over here. So I have resistance R1, 3 in parallel with resistor R2, and this is my resistor R4. So now you can see that resistor R1, 3 is in parallel with R2. And I have over here my points A and B. So R1, 3, 2. Okay, so I have R, I'm going to write this in order. So R1, 2, 3 is nothing else, just R1, 3 times R2 over R1, 3 plus R2, where R1, 3 we found is equal 2.5 kilo ohms times R2, which is equal 2 kilo ohms, over 2.5 kilo ohms plus 2 kilo ohms. Okay, this is equal, I have 2.5 exponent 3 times 2 exponent 3 divided by open parenthesis 2.5 exponent 3 plus 2 exponent 3. Okay, this is equal 1.11 kilo ohms. Okay, so this is the resistance, which simply represents these three resistors together. Now we can find the RTH, or maybe I'm supposed to redraw the circuit one more time so we get something like this. So we have resistor R1, 2, 3, okay, and this resistor is in series with R4. Okay, and I have my points A, B. So RTH is equal simply the sum of these two resistances. So I have R1, 2, 3 plus R4, where R1, 2, 3 is 1.11 kilo ohms plus R4, which is equal 3 kilo ohms. So RTH is equal 4.11 kilo ohms. Okay, so we found the Thevenin's resistance, and we found so far the Thevenin's voltage. Now the problem is asking me to find the current which goes through the resistor RL, and I have to find also the voltage across resistor RL, and I have to find the power, okay, at this resistor. So next I'm supposed to simply draw the Thevenin's equivalent circuit. So this is my RTH, this is my VTH, okay, and I have my points. These points are my point A and point B. Okay, so next I'm supposed to replace my resistor RL. Remember at the beginning we took off, okay, we just took away resistor RL. Now we're supposed to put this resistor back into the circuit. So I'm going to put this over here. This is my RL. And as you can see, we have sample series circuit. Okay, so if you want to find the current which goes through this resistor, we're supposed to find the total current in this circuit. And in order to do so, I'm going to use Ohm's law. So I have IL is equal VTH over RTH plus RL. This is equal, VTH we've found is equal to 8.88 volts. So I have 8.88 volts divided by RTH 4.11 kilo ohms plus RL, which is equal to 2 kilo ohms. This is equal 8.88 divided by, open parenthesis, 4.11 exponent 3 plus 2 exponent 3. I do everything step by step because many students forget about the exponents. We have to include exponent 3 because we're dealing with kilos, okay? In order to get the right answer, you're supposed to make sure that you're going to enter proper information into the calculator. This is equal 1.45 milliamps. Okay, so this is the current which will flow through the resistor RL. But keep in mind that this is just the Thevenin circuit, but in real life this current will flow through resistor RL of this circuit. Next, we're supposed to find the voltage across resistor RL. We can use voltage division law, or you can use simply Ohm's law. I'm going to use Ohm's law. So VL is equal IL times RL. So IL is equal 1.45 milliamps times RL, which is equal to 2 kilo ohms. This is equal 1.45 exponent 3 negative times 2 exponent 3 equals 2.9 volts. Okay, so this is the voltage across the resistor RL. Next, I'm supposed to find the power at this resistor. Okay, so formula for power says PL is equal IL squared, for example, times RL. So I have 1.45 milliamps raised to the second power times RL, 2 kilo ohms, will give me the power. Let me use the calculator. So I have 1.45 exponent 3 negative to the second power times 2 exponent 3. This is equal 4.2 milliwatts. So this is 4.2 milliwatts. Okay, so this is the power at the resistor RL. The problem is asking me to find the value of the resistance RL in order to get maximum power at the output, because probably this one is not the maximum. Okay, so when we have maximum power at the output, you will get always when the Thevenin's resistance is equal to the load resistance. Okay, so at this condition you are going to have the maximum power at the output. So in order to get the power max, okay, so this is you're supposed to make sure that RTH is equal to RL. So in our case, RTH is equal 4.11 kilo ohms. Okay, so your new value of RL is 4.11 kiloohms. Okay, so this is the value of resistance, okay, in order to get the maximum power. Now let's check if this power is going to be at least greater than this one. Okay, so what we're supposed to find again, we're supposed to find the voltage, right, VL, across the new value of resistance RL, across the new RL. So because these two resistors are the same, so the voltage TH is going to be divided in half. So VL is going to be equal 4.44 volts. Okay, let me remind you one more time. Series circuit is voltage divider, and because these values are identical, because we said in order to get maximum power at the output, RTH must be equal to RL. So that's why my VL, voltage across RL, is simply half of my VTH. So if you want to find the power, new PL max in this case, this is going to be nothing else, just VL, okay, raised to the second power over RL, where VL is equal 4.44 volts. We have to raise this to the second power over RL, and RL is equal 4.11 kiloohms. Now I'm going to use the calculator. So I have 4.44 to the second power divided by 4.11 exponent 3. This is equal 4.79 milliwatts. So this is 4.79 milliwatts. As you can see, the power is greater than the one which we obtained earlier. Okay, before we got 4.2 milliwatts, now we got 4.79 milliwatts. If you want to check if it is true, you can choose the value greater than 4.11 kiloohms and calculate the power again, and you will notice that the power which you'll obtain is going to be less than 4.79 milliwatts. This is the maximum power which you can get. Okay, so at this moment I can say that the problem is solved.